So, welcome our panelists. We will talk about Kubernetes native networking, and the question is that are we there yet? We will seek an answer to that. Yeah, let's do a short introduction round, please.
Yes, I will start. So I'm Lionel, Jouin, working at Ericsson Software Technology, mostly involved in SIG network, around multi-network, CNI, and the Kubernetes network plumbing working group.
Hey everyone, I'm Surya. I'm an engineer working at Red Hat on OpenShift networking. I also contribute to SIG network around network policies mainly, but also I'm a maintainer of OVN Kubernetes, which is a CNI or consumer of multi-networking.
My name is Antonio Ojea. I work at Google Cloud, and I'm a Kubernetes core maintainer and TL in SIG network and SIG testing. I'm happy to be here.
And from my side, my name is Csatari, and I'm working in the open source program office of Nokia. And I'm a former co-chair of the Nokia TSC, and I'm also working on the RE2 part of Nokia. First, we thought that maybe we should summarize a bit in some slides what is the problem domain, what we are talking about. And the first question is, like, what are the use cases for multi-networking in Kubernetes? And we collected a couple of these use cases. For example, we can have a use case when we have a GPUs, and I would need like special connection with RDMA capabilities to use GPU direct, and I would like to have all the rest of the traffic on my, let's say, normal network interfaces. Also, I could have a use case when I would like to have a secondary interface where the interface is connected to a VLAN, to a storage network, so it's like a storage traffic segregation. I could have additional interface needs for the data plane and control plane of an application, or simply just use like network segmentation in case of multiple virtual networks. So all of these use cases are there, and we have like different solutions currently for these use cases, but we would like to have evolve from these solutions. We will discuss this shortly in the slides. So Surya, please explain what is the current solution.
Yeah, so how many of you are using multiple networks in Kubernetes here in the audience? And how are you doing it? Is it network attachment definitions? Raise of hands. That's some hands. Anybody who's doing multi-networking without using NADs today? I see two of you. Do you want to shout out how are you doing it? Just for Metal LB and here? Okay, so something vendor specific, etc., or implementation specific. So I think that is also the crux of our problem, which is we have a lot of variation in how we do multi-networking, but everybody here, one use case I think is very common, that we are all trying to address the same umbrella of problems, but precisely there's variation in exactly what each user wants. Like some of them might want the secondary use case connect to VLAN, some of them might want the network segmentation. So the use cases that Gergely just mentioned. And today one of the many ways is using network attachment definitions, which is the API that you see on the screen. And it's less of an API, but more of a spec JSON blob where you can customize what you put there. And usually Maltese or some CNI is going to implement it, have their own opinionated way of doing it. And like I said, I come from OVN Kubernetes, and we have one way of doing it. I'm sure other CNIs have different ways of doing it. So today I think most of our ecosystem projects rely on doing it the NAD way, or like they were saying, Metal LQ, but there's different ways of doing it, right? So, but today in the panel, I think we're going to try to converge on how we should do it in Kubernetes, if so. And so I would like to hand it over to Antonio, who will take us through the timeline of some of the events that has happened for us to transition from, we are at NADS today. This is what we're doing today, but where are we going to go to the future? What is happening today in the community? Where do we plan to go ahead is what Antonio will take it off from, so over to you.
Yeah, well, the first step is, as Surya was saying, is everybody was doing something different and was an interest on doing everybody the same, right? So the first proposal was to define some common APIs, and that was the first step that you can see in the right. The proposal draw a lot of discussions and raised a lot of questions. So it was clear some of the use cases, but when we talked about multi-network, there were different people, there were different personas, there were different use cases, and there was a big problem. And I'm as the TL and maintainer, I need to review that, and one of the main problems was, okay, we want to do this, we need to re-architect Kubernetes entirely, right? And in Kubernetes, we have a strong commitment with compatibility, with backwards compatibility with API and semantics. So if we want to address one solution like this, we want this to be portable, right? We don't want that everybody do their own thing, and then these APIs work differently in different Kubernetes clusters. And so we end with the discussion as, okay, we are missing these high-level APIs, what we can do, right? And this opened another set of questions that is the key and I kept that you see references. Okay, in addition to these high-level APIs that we may know what we want to do, but we don't have clear how to do it, we have another problem is how do we integrate these low-level APIs? People is using Multus, is using CNI, other people is getting out of the network namespace to create interfaces. So we have another problem, the low-level API, right? And with all of this in discussions in network, we presented, okay, let's try to step back and see what can we do today. And then we found, okay, we have Linux devices, we have CNI, we have Ojea spec, we have all this other stuff, but we are not able to create a coherent vision, right, to put this all together. And this is when we went to Paris, and in Paris we started a discussion with the community. And you can explain more about that.
Right, it was mostly discussion from people from Multus and myself, so Tomo, Doug, and some others. And the discussion were mostly about how to integrate this Multus concept into Kubernetes. And at the same time, there was a lot of talks going on, especially about this cap for multi-networking. We also had new ideas coming mostly from Antonio to move towards more or common features that is currently in development in Kubernetes. So I'm mentioning here DRA, dynamic resource allocation, that allows you to request and allocate devices. So devices can be any type of devices. We can consider a network interface as one type of device. So during this year, there was other talks around this, trying to configure this network interfaces in the same way as Multus, but still using DRA now. And we identified some of the missing parts, especially, for example, about returning the status. So we have this cap where we have the DRA driver, so some kind of extension of Kubernetes that allows us to return the status so we can get the IP addresses and a network interface name. So this feature is in alpha today in 1.32, it will be in beta in 1.33, and DRA is currently in beta, but is moving quite quickly and expecting it to have it in GA from 1.34, if I remember correctly. And at the same time, I think there is other developments around DRA, for example, this cap 5075 that is very interesting, where we can claim capacities or consume capacities on devices, where we can, for example, allocate some bandwidth. We can do all scheduling things around it, and I think it's quite interesting. Maybe you should start the questions.
Yes. Let's move to the questions. Yes. All right. So first question, what I wanted to ask is what's in the title of the talk. So there were lots of work done in the area of multi-networking in Kubernetes, but are we there yet?
Well, we were rehearsing before, and that's the big thing is what multi-network means is different for different people. What I think that we have now a clear idea where we want to get, and we are start walking the path. So we are closer, but I cannot say how closer.
But definitely we are progressing in the right direction, right? Like I think we saw that different people are doing it differently, but the fact that the Kubernetes community is coming together to now think and do a standardized way of this, I think is the right way forward. So we are making progress. Are we there yet? We have to define the there, right? So.
And yeah, in my opinion, it depends on what use cases we're trying to solve. In my case, I want services on top of secondary networks. I could already do that using a lot of different hacks, I would say, but having something that is completely native in Kubernetes would be very interesting. And today, some features are missing, but I think it's on the very right path today.
Okay, so we learned that there are different use cases, and there were lots of work done in the area, but we still having some gaps. So, what do you think? What is the biggest challenge in Kubernetes multi-network?
So one of the main things is that, as I said before, Kubernetes makes a strong commitment with backwards compatibility, right? And Kubernetes was created with a concept of flat network, right? Where everything is an endpoint, everything is reachable. So trying to get all these new concepts, well, it's not new concepts, all these multidimensional concept of networks is theoretically, let's say, simple because we were doing this before, but practically it's complex, right? You need to think that we have certificates. We have a lot of features that depend on this, on the network concept of reachability, but in the moment that we put multi-networks, these things doesn't work well. We have, how do you implement result.conf, the kubelet profs, there was a talk yesterday about that. All these things we need to work out, right?
In my experience, the most complex part would be maybe the communities. The community is very fragmented among different groups that are or sometimes not really talking to each other. I'm thinking about CNI, which is another incubating project within the CNCF. We have the Network Working Plumbing Group, that is a group that is a bit on the side, working on everything around multi-network now. We have Multus, Whereabouts, and a lot of cool projects. I'm thinking about, for example, the SRV device plugin or operator. And then we also have the multi-network group. So it's a lot of different groups that have different opinions, and it's a bit hard to get them working together, or even to attend all those groups if you want to follow or have the full picture of what is multi-network today, what we should use, and how it will evolve.
Yeah, and echoing what both Antonio and Lionel said, I can wear one of the CNI hats, which is the Ovian Kubernetes maintainer hat. As you can see on the timeline of events here, the KEPs kept getting opened, they kept getting closed. Kubernetes is 10 years old, and yet we have a problem with such a large community getting consensus, because the problem is complex, I get it. But it took a lot of time to reach where we are with TRE and with everything coming. But by that time, the community had to get something out. So like, for example, Google did their vendor-specific thing, or Ovian Kubernetes is having their opinionated way of doing multi-networking. So I think the main problem is now when we bring these pieces together, and then like Antonio was mentioning, the traditional Kubernetes networking model, which existed or was formed 10 years ago when Kubernetes started, doesn't fit. So something as core and crux as kubelet and how the probes are working with your multiple interfaces doesn't work. So it's not anymore about can we make it work with hacks. It's really about how do we come together as a community, how do we solve this, even if we are fragmented, like Lionel was saying. It won't help us move forward, right? Because we are trying to solve an umbrella of same set of problems, even if it is niche, but in different ways, which won't fly. So I think that is the biggest challenge for us, like the time that it takes sometimes upstream to get things moving, but it is still the right thing to do and to stick with it. And now we are all moving in the right direction. So for me, I think that is a great way of solving that challenge.
Yes, very good. So now we learned that there are different use cases, there are already different solutions. So what is the main motivation to do like a Kubernetes native solution? Like I know that you said that this is the right direction, Surya, but why is this the right direction? Why cannot we have like still Multus and all these vendor-specific solutions?
Yeah, if I talk about my use case for services on top of secondary networks, I would implement some kind of hackish solution for services. I would take an example with the KEP that I created that wants to have a label on services to disable the endpoint slice controller, so we can select secondary IPs which get rejected now because it's not really a native solution. It's a Multus-like solution where we have a new label that enables a feature, and that might cause other problem within Kubernetes because it's not fully integrated. It's just a label. And then we would have this solution for the services for my use case, and we will rely on an existing hackish solution that use annotations for Multus to attach secondary network services, and probably this is not really the right way. The right way would maybe start from the beginning, network attachment, then having services. I'm thinking about Gateway API that could bring, for example, new features and a modern way to have services.
And even extending beyond what Lionel is saying, even if we continue with services, but it even begs the basic question. Service is a Kubernetes API. We have always traditionally had a service sider, which is from where you get your cluster IPs. But how many of you in the audience will think, would you say that you want a single service sider still, even if you have more than one network in your cluster? Or what does even having more than one network mean, right? Like, so do you think that you should have multiple service siders in your multiple networks? No? Nobody thinks that? Yeah, a few hands. Or do you think that the same service sider should be flat across all your networks in your cluster? Well, Gergely is raising his hands for both. So what I'm trying to say is these are basic questions which we haven't thought about or designed. And now if Multus or even having a label is a way of doing it, like, so it's nice he has a KEP there because it's about talking through some of those high-level abstractions before even getting down to, okay, now how do we implement it? And I can say the same coming from Network Policies Working Group. How would that look like? If you have multiple networks, or if you have an extra interface or a net device on your pod, where does the IP come from? Like, there are all these open-ended questions, right? And because network policies heavily rely on pod IPs, what if you have multiple pods with same IPs, which is possible? So I think that is where that is one of the main reasons why I feel we should standardize, right, to answer your question, to come together to at least talk about these high-level abstractions and to agree upon some of the common semantics, because these are Kubernetes APIs at the end.
Yeah, I don't have much to add. It's just that, right? Kubernetes is an open source project. It fits from users, it fits from use cases, and the key thing from Kubernetes is portability, right? All of you do kubectl, apply whatever, and it works. And we want that to work in any platform, in on-premises, in cloud, in whatever cloud. So you care about your workloads, and that is very complex to implement, and especially if you deal with this complexity of multiple networks and all the stuff. That's why it's taking so long. Maybe it's easy to think about it, but it's super complex to implement, and make it portable is a nightmare.
Okay, so you convinced me. We have to do this. So as we learned from the timeline, one of the current proposed solutions or selected solution is based on DRA, dynamic resource allocation feature of Kubernetes. Can you explain a bit why is that? What's the connection between networks and resources?
When we started with the CAP discussion, so we identified this problem, right? So we don't have the primitives in Kubernetes to build things, right? So one of the approach was, let's create the high-level APIs, and then people will figure out how to do it. And then it's when we broke compatibility, right? And at that time, a lot of people were working on the GenAI with DRI and all the stuff, right? And we just needed an API that was able to tell us, I want to connect this pod to this network. But instead of saying network, we were saying this network interface, right? So we talked with this working group and give them our requirements. So say, okay, we need to express this, and we need to express this in a native way. We want the scheduling. We went out to scheduler. We want all these Kubernetes things to be able to do the right thing when we say we want to connect to this network, right? And we found this working group, and they accepted our requirements. And now we just say, Lionel implemented the CAP, and we have another CAP, so we are building on top of that. And now in 134, if we go GA, you will be able to say, I want to connect to a network. Not really a network, it's going to be a network interface, but the functionality is there. Now we need to keep growing on that. We need to keep building, creating these high-level APIs, give a better user experience, but the native functionality is in the core, and that guarantees the compatibility of your applications.
I would like to add to what Antonio says about they accepted our use cases. I would like to add that they already had some kind of use cases because, for example, SROV was part of it. Currently, SROV is handled by device plugin and CNI. So it would be a bit fragmented if we would take two paths, one for multi-network that will configure some kind of interfaces in one way that will have its own scheduling features, and we would have the array that would schedule some other type of network devices for some reason, and that will use different scheduling mechanism, which makes things even more fragmented and even more complex to handle, I believe.
And just to get a gauge of the audience, how many of you know about dynamic resource allocation effort in the Kubernetes community? There's 3-4 hands. Maybe, do you want to take a moment to explain the DRA, what DRA is? We never touched that.
Okay, DRA is this dynamic resource allocation. Kubernetes had a problem on managed hardware, right? Kubernetes was created to consume CPU and memory. And then the hardware vendors have to use this device plugin. That was very, let's say, simplistic. So they created all these high-level APIs that are allowed to express you a native relation with the hardware, so you can indicate the pod to attach hardware devices. That's at the high level what dynamic resource allocation does. It improves the relation of the pods with the hardware in the host, right, via these APIs, and allow implementations to, it's extensible, so you can create multiple abstractions on top of this API. I think more or less that.
Maybe I can add a little bit about this. It allows you to list all the devices or I would say in my own words, but it allows you to expose all your devices that you have on your nodes, and then you can claim those devices or utilize some capacity of those devices, and then Kubernetes will schedule your pod based on your requirements. So you can have a lot of requirements. You can, request a lot of devices, different devices, so Kubernetes will have to pick the right node where this is available. And then the second part of the array would be to configure this device in your pod. So it will move the device, it will configure it according to the configuration that you are giving, and then the last part is the status. So it will report the status, give important information, for example, the IP addresses with the CAP that we created and that we worked on, and can probably in the future give more features like downward API and even more.
Yeah, and tying that back to the question, which is why is DRA the right way or the way we move forward? For me, it just feels so natural that we've solved the scheduling problem using DRA, that is just leveraging the whole network device just being another resource that you can have. So based on your type of nodes, you're able to schedule things and claim it or have an affinity for it. So it feels so natural to leverage that also for networking. And that I think is like the key success of it. And of course, like Antonio said, it's a net device. And now you need to frame a concept of what a network means. And so there's a lot of work left to do, but DRA feels like the first right step that way.
All right, we have 5 minutes left, and I would like to have some questions from the audience, but I would like to ask the combined big question, like when can we use multi-networking in Kubernetes and in the whole ecosystem?
For scheduling and attaching network interfaces, 134 is the goal of DA. We have already two DRA network drivers that are being worked on, so I expect in 134 people being able to use a DA feature to attach network interfaces to the pods natively.
And there is a SIG network, multi-network working group, which is working on solving some of those problems. And like Lionel was saying, services, network policies, all the ecosystem APIs still needs more work. So I think, like Antonio said, base is going to be there in 134, but for more niche use cases, we still have some work to do.
Yeah, I don't really have so much to add. Just as you mentioned, if I want services, then I would need to wait a bit more. But yeah, it really depends on the use case. I think it goes back to one of the first questions.
All right, thank you very much. Any questions from the audience? Whatever you wanted to know about Kubernetes multi-networking, but were never the chance to ask. Everything is clear. Okay, cool. Then let's talk about the ecosystem a bit. Like we know that the Kubernetes itself has the multi-networking feature, but there are lots of things around Kubernetes. So how do you see when the ecosystem will catch up, let's say, with the multi-networking capabilities of Kubernetes?
Well, we started to that path some time ago, right? We have now service-sider that is decomposable, right? We have an IP address object. We have a proposal for Gateway API to make a Gateway API multi-network. So all this, for the end user, maybe not visible, but for the developers of the people that is in the day-to-day, you can see that there is a lot of work going on, right? It may take time, open source take time, but I really think that we are progressing at a good pace.
Yeah, and I can speak from at least the network policy API, admin network policy API that we're developing. We are starting to think about how the API would work with multiple networks. I'm not saying it works today, but at least it's coming to us as, it's not an afterthought anymore. While designing the API, we are thinking about, can it be extensible? And I think that is the right way to look at it, which didn't exist before. So.
On the multi-network community, we also have some timeline where we are aiming for alpha release of the pod network object that will allows you to express the multiple networks in your cluster. So this is something that we are looking for. I think it's quite good to mention it because as Antonio mentioned, this cap is from 2022 and now it's going to a different way. So I think it's quite good to mention it.
All right, thank you. So yeah, time is up, but let's talk about the community, where people can participate or follow up on the discussions.
Right. I think we have 4 large communities that are quite important here. I would say that the first one is CNI. We are mostly talking about multi-networking, CNI 2.0, how to evolve CNI to make it scheduler aware, having validation, for example, and quite cool features that would make it more compatible with Kubernetes. The second one would be the working group device management, where it's a group composed of different SIGs in Kubernetes, composed of SIG network, SIG scheduling, SIG node. We are talking mostly about the array. It's not only about networking, but some of the part, as Antonio mentioned before, is now about networking, since we are exposing these use cases towards this API. The other one is the multi-network community, where we're talking about this pod network. It's composed of the original people who created this CAP, and the idea now is to move towards something more like Gateway API, a bit an extension, official extension of Kubernetes, but still with the aim to have it natively at some point, I would say. And the last one is the network plumbing working group, where we are always almost discussing about multi-networking, especially around Multus, and how we can evolve Multus towards something more standard. And something that I forgot to mention also about the plumbing group, the device management and this CAP 5075 is that we have Peng from IBM. I think it's quite good to mention her, that she's doing a great job running this CAP. It's a lot of work, and she's mostly working on within this working group device management. So now we have a meeting on every second Wednesday morning, because she's from Japan. So if you're from Asia, you can also join this group.
Thank you very much. That was our panel, and let's have a big applause for the panelists, not only for being in the panel, but for your work, what you are doing for the multi-networking. Thank you, and then we have like a 5 minutes break, and then we will learn about Silva and GitOps.